Welcome. Today we will learn about the OES or optical emission spectrometer and its significance in day-to-day working of Indian Railways. OES can be called as the backbone of modern MNC laboratories as its usage extends from analyzing in-service lube oil in diesel sheds, assessing chemical composition of new incoming metal components in workshops, doing ladle analysis of the melt in production unit foundries, and failure investigation and R&D activities at MNC Directorate RDSO. Let us see the scope of spectroscopy in Indian Railway starting with diesel sheds. The usual physiochemical analysis method such as viscosity, water contamination, pH of used lube oil provide information about fuel dilution, cooling water contamination, additive depletion. However, these tests do not provide any information or any indication about the wear pattern of diesel engine components. The lubricating oil used in diesel locomotives can be considered as the diagnostic medium for analyzing this wear pattern because the oil carries with it metal particles generated by the wear contact. To elaborate, metals in concentration level of as low as parts per million get suspended as colloids in the in-service lube oil of diesel locomotives. The source of these fine metallic particles is the wear of oil-wetted metallic engine components caused by their relative motion. Abnormal wear modes such as corrosion, severe wear, abrasion, spalling cause an increase in concentration of wear metals in the lubricating oil. The wear pattern of major engine components can only be analyzed by estimating the concentration of these metals by means of an OES. The wear metal concentrations below abnormal can be actually tolerated. However, abnormal and above, that is critical, need to be rectified with suitable corrective actions such as replacing the worn components. For example, during testing of lube oil of a WDM2 locomotive, if the concentration of chromium goes beyond 5 ppm, the cylinder liner present in the engine block needs to be inspected for wear of its inner chrome plating. Spectrometric analysis of used lube oil is conducted as per ASTM D6595, which is the standard test method for determination of wear metals and contaminants in used lubricating oil or by rotating disc electrode atomic emission spectrometry. Thus, we see that the analysis gives valuable information regarding the internal condition of a diesel locomotive and helps in predicting required maintenance for preventing the occurrence of major failures on account of abnormal wear of engine parts. Spectrometric analysis can also be used for a similar analysis of fuel oil used in diesel locomotives. Now I will describe about the scope of use of OES in workshops and production units of Indian Railway. Wet analysis using group analysis of elements was the predominant method for analyzing chemical composition of ferrous and non-ferrous metals in the Indian Railway CMT laboratories. However, with the advent of optical emission spectroscopy, workshops and PUs utilize this technique for testing the material composition of incoming ferrous and non-ferrous metals, metallic items coming for failure investigation. It is also used for identifying the grade of steels used in coach manufacturing units, especially in case of stainless steel LHB type coaches where a number of different grades of stainless steel are being used. Foundries in wheel and axle production units use this technique for doing ladle analysis of molten iron, especially for estimating trace elements such as nitrogen in steel. Elements shown in color can actually be analyzed or identified by means of an OES. Now, this OES has got certain assured advantages over the conventional techniques as it is quite a sensitive instrument which can detect the presence of trace elements up to parts per million and is able to fetch precise results in up to 45 seconds of time. Hence, a large number of samples can actually be tested within very short time without actually compromising on accuracy. And for doing all this, it doesn't require too much or large chunk of samples. A metal sample of few width or liquid solution of 2 to 3 ml volume is enough to deduce the results. Thus, to conclude, the scope of use of OES in Indian Railway can be broadly divided into two parts. First, testing the wear metal concentration of lube oil of diesel locomotives in diesel sheds and testing chemical composition of metals in workshops and production units. It is also worth mentioning that varying concentrations of metals ranging from ppm level to 20 to 30% can actually be tested using an OES. Having discussed the scope of use of OES, now I will describe about the principle behind working of an OES. An OES works on the principle of spectroscopy, which deals with the interaction between light and matter. Spectroscopy utilizes the wave nature of light and the fact that each element has a unique atomic structure. The most important consequence of interactions between light and matter is the absorption or emission of light by the atoms. This absorption or emission can take place throughout the complete spectrum of electromagnetic radiation. However, in case of emission or optical emission spectroscopy, we utilize visible spectrum and part of ultraviolet spectrum. The precise ranges from 130 nanometers to 800 nanometers. The entire principle of spectroscopy is based on conservation of energy, the energy being conserved with the atom or nuclei. The amount of energy accepted by the atom or nuclei for going to higher energy state is equal to intensity of emission spectrum or absorption spectrum for that matter while returning to lower or ground energy state. This spectrum is analyzed for identifying the presence of the particular element and for determining the composition of that particular element. So how it all happens? A sample of the metal is brought in contact with the flame in either the form of solution or solid form. The flame has a temperature ranging from 3300 to 10,000 degree kelvins. This thermal energy supplied by the flame actually does two jobs. It breaks the chemical bonds to create free atoms at the sample interface without actually penetrating through the surface. It also excites atoms to excited energy state, which subsequently emit light while returning to ground atomic state or lower energy state. This light has a particular wavelength or frequency determined by the energy of the electron in transition. To quantify and identify the element present in the sample, these wavelengths must be separated. This light is dispersed into spectral lines using a dispersing element such as a prism or grating. Now these spectral lines have got a unique characteristic as they are unique to one particular element. For example, in case of a hydrogen nuclei having only one electron in the orbit, the spectral lines will look like this, while in case of an iron nuclei having 26 electrons in the orbit, the spectral lines will look like this. Two most important parameters that are measured during the emission process. The first one is the wavelength of emitted radiation. This wavelength of emitted radiation gives the identity of the element or the element which has emitted the radiation. The second most important parameter is the intensity of radiation, which is proportional to the number of atoms present in the element, that is, to the concentration of the elements. Intensities received from the optical system are converted into electronic data and interpreted by means of a readout system. Thus, we come to the conclusion of part 1 of the Spectro video series, in which we have seen that the scope of use of OES or optical emission spectrometer in Indian Railway and the basic principle behind working of optical emission spectrometer. In part 2 of this video series, we will be discussing about three major components of OES and step-by-step working of two most common type of spectrometers used in Indian Railway. We will also be seeing about factors responsible for reliable working of OES and how to calibrate and standardize our OES equipment. Hope the video was informative. Thank you.